As a people, we cheat, whether it's by taking a quick glance at our neighbor's paper during a test or by embellishing on an application. We've reaped a reward we did not earn. And for a cheat to be successful, we expect some level of cunning in the cheater. Now compare that expectation with what is expected of an animal. Whether we're talking about real animals or referring to someone as being animal-like, the behavior we're describing is primal, straightforward, not a lot of thought put into it. But what if I told you that cheating can be performed by almost any life form, regardless of intelligence, and that some can do literally nothing to stop themselves? Mutations and selection can cause the loss of an ability whose function is relied upon by more than just one organism. Examples include sea anemones and clownfish, or you and the bacteria inside of you. So how do those who are getting cheated react? Let's take a look at a real-world example and find out.
The social amoeba is a good model system to analyze the cooperation and conflicts in a population. Under starvation, thousands of amoeba will converge to form a fruiting body. Most cooperators will form a stock and die, while cheaters will form spores and survive. This is an altruistic behavior of cooperators because the overall survival and dispersal will be higher by their deaths. As a result, selections will favor those cheaters, but whether cheating will eventually lead to success is not very clear. An experiment is therefore set up for testing the ratios of cheaters and non-cheaters. Genome sequencing is then used to find the frequency of each allele. That leads us to the next question: what are selection types likely to occur?
Let's use a few real-life events to illustrate these types of selection. In arms race selection, a new and improved gene beats its competitor by allowing more competitive organisms to be born. Compare this to the introduction of the light bulb in the late 19th century, which had a strong effect on human productivity, causing older lighting methods to die out. In purifying selection, a gene presents an advantage that has a short-term success but is eventually outperformed by the original genes over time. Think of any fad or one-hit wonder as an example. They're here today and gone tomorrow. In stalemate selection, organisms in competition with old and new genes are able to exist in an equilibrium where there is a constant back and forth trend between gene frequencies on both sides. This can be seen during presidential campaigns where neither competitor has an overall advantage.
So was the selection arms race purifying or a stalemate? It was actually a stalemate. Neither the cooperators nor the cheaters got the upper hand. But why is that? Well, see, the cooperators helped make the stock, and since the cheaters always rose to the top, their cheating had a higher frequency in the gene pool over time. But when there are too many cheaters, there are not enough amoeba to build the stock. In order for a stock to be built, cooperation is selected for and ends up having a higher frequency over time. So in reality, the cheaters could only cheat because there were enough cooperators. Using different tests, it is shown that the cheating population rose in frequency quickly, but then also experienced a lot more selection. Many social behaviors are inherently frequency dependent, where the fitness of a given strategy is dependent on whether the individual's social partners employ the same strategy or not. The results not only indicate stalemate as a possible outcome of social conflict, but add to a growing body of evidence that stalemates may be a common outcome in conflict-driven systems. So the question still remains, do cheaters always win? Not in this case.